Okay, passage 7. We're going to have a look at that. And I am just going to look over the passage and... So what do I see? We've got a couple of graphs here. They have a key, and one says it's this Compton effect, photoelectric effect, pair, production, carbon, same up here. Oh, except this one's lead. Okay, so it's... But they look fairly straightforward. A wee bit... Okay. And I'll look up here, and it looks like they describe what the different effects are. This is how I see this. It has this much writing for study 1. Chances are at least 1 or 2 questions you'll have to read some of this passage. It looks really kind of involved, so I think I'd rather just wait until the questions tell me what exactly to look for. But they're basically what I'm saying is generally they're not going to write this much and have you just not need it at all. If it's only a few sentences, or a couple of, 2 or 3 sentences, you might get away with just looking at the graph. But when they put in that much effort, you're probably going to have to need it. So just know that that's probably where you're going to find some information. But for now, I'm just going to read the first part of it. And it says the 3 primary interactions between photons, particles of light, and matter are, okay, Compton effect. Photon collides with and gives some of its energy to a free electron E minus. The photon and E are scattered away. Okay. Photoelectric effect. A photon is absorbed by and gives all its energy. Okay, there's a difference. To an E minus. Did I write over that? I sure did. Another E minus, bound to an atom, the E minus is scattered away. In pair production, a photon passes close to an atom and is transformed into an E minus and an E plus. Same thing but the opposite charge, converting energy to mass. Fair enough. And the E are scattered away. Alright. So now I know what those 3 are. I'm going to get into the questions. In study 2, approximately, okay, so it's not going to be exactly on the graph, what incident photon energy was P for the Compton effect and PB is lead at its maximum value? Alright, so we need to find study 2 first. We need to find what incident photon energy P. We need to find P. That's number 2. We need to find it for the Compton effect in lead. And we need to find number 4, its maximum value. Alright, so we've got our 4 steps. Let's go. Study 2 is over here. So we've done step 1. Approximately what incident photon energy was P for Compton effect? Incident photon energy is down here. What incident photon was P? P is up here. For the Compton effect, we know it's the dotted line, so it's the one that's up here. And it's saying in lead, okay, PB, we've got that there. When was it at its maximum? Well, its maximum would be when it was its highest. And we need the incident photon energy. We need its value down here, and that would be, this is 1, this is 5, so it'd probably be about 2, and that's C. Alright, number 36. In any given event, what scattered particle were registered by the detectors? Scattered particles were detected by the detectors as evidence that the Compton effect, the photoelectric effect, and the pair production respectively had occurred. The symbol for photon is, I'm just going to call it Y. Okay, so we have to go to the explanations up here, because it was telling us that things were turned into E's and E pluses and everything else. So, we need the Compton effect. A photon collided with and gives some of its energy to a free E minus. The photon, anything. So the photon still exists. and then it gives some of its energy to an E minus, so it'll be Y E minus. So we need that, so we've got that in F. We don't have it in H and J, so they're gone. Photoelectric, we're looking for the difference. We're looking for, is it E minus or E minus E plus? And once we get that, we'll know our answer. Photoelectric, a photon is absorbed by and gives all its energy to an E minus. Bound to an atom, the E minuses are scattered away, so it's E minus. So we have YE, we have E minus. We don't have to look at the third one because it's the only one that satisfies the condition, so it's F. Pair production cannot occur unless the incident photon has sufficient energy. Right, pair production can't occur unless it's sufficient energy. Based on the results of studies 1 and 2, so that's going to be step 1, we need both of them. The minimum incident photon energy for pair production is, so we're going to have to find pair production closest to which value, and then we're going to have to find 3, the minimum value of it. All right, we've got our 3 steps. Right, so we're looking at studies 1 and 2, and that would be figure 1 and 2, since that's figure 1 and 2 has the results. So we've done step 1. Step 2 is find pair production the incident photon production, the incident photon, this is along the bottom here, energy, and we need it for pair production, and that, I'm going to increase this. Pair production is a small dotted line, because it's right here. So in this graph, we've got the probability, we've got P up here, and we have this. So the pair production doesn't start till here, right? There's nothing going on from here, and then we start to see the line here. So here it starts at 1. So 1's in the game. And let's see, in this one, same little dotties along the bottom. It appears here. There's nothing for it between here and here. And then we see it first here again at 1. So the answer is 1. That's B. Right, which of the following questions cannot be answered by an analysis of figure 2? Okay, so that's just a matter of reading the answer choices. There's no point in looking at the thing. So we know figure 2 is this one. Right, what is P for the photoelectric effect in lead at an incident photon energy of 1? So what is P? That's 1 at 1. So photoelectric is a solid line, and at 1 it's a bit here. So yes, we can find that. So that, I'm ticking it, but it's going to be the one that gets the cross that will be the right answer. So we can find that. We're looking for the one that we cannot. Answer. What is the probability of an event being successful in lead at an incident photon energy of 1 MeV? So probability, since this must be probability here, since it's P%, of an event being successful at an incident photon of 1 MeV. So 1 is here, an event. I don't know what an event is. What's the probability of an event? I mean, it's measuring these effects. It doesn't really, that one doesn't make sense. I'm leaving that one. That doesn't make sense. I don't think that's right. H, above what instant photon energy P for pair production is higher than 50%? Above what instant photon? So P above what production for pair production against this dotted line here. This is probability. 50% is a bit here. So yeah, we can find that. Can we find J? At what instant photon energy are P for the photoelectric effect and P for the pair production equal? So we need to find out if the photoelectric graph and the pair production graph intersect. So Photoelectric is the solid line, that's it coming down here. Pair production we know is the dotted line and it starts here, so we see that they do actually cross here, so that can be found by a process of elimination. I'm going with G. Right, 39. Which of the following statements, G moved down just by itself, which of the following states about the data used to generate the plots of P versus incident photon energy is correct? The plots shown in figures 1 and 2. Only data from successful events, only data from unsuccessful, mixture. All right. The graphs don't tell me anything about whether it's successful or unsuccessful, so I'm going to have to go to study 1 and read it. And I'm going to read it quickly because I'm just looking to see if there's successful or unsuccessful anywhere. So I'm just going to scan it and look for the words successful and unsuccessful. Okay, hang on. A successful event was registered. All right. When an instant photon interacted with a slab, a successful event was registered. When the photon passed through the slab without interacting, it was an unsuccessful event was registered. Okay, maybe it's both. In each successful event, the energy of the incident photon and the type of scattered particles were recorded. Oh, in each successful event, the energy and the type were recorded. When 500,000 had occurred, when 500,000 successful had occurred, data from these events. Okay, so it's just the successful ones. When 500,000 successful ones had happened, that data was then used to calculate. So it's A. It's only successful ones. Right, now we get to number 40. An element is considered light if its atomic number is less than that of iron, heavy if its atomic number is greater than iron. Based on the results of studies 1 and 2 for 0.1 MeV photons bombarding light elements and heavy elements respectively, which primary interaction most likely has the highest P? This study description doesn't say anything about light or heavy, but I did see that this is carbon and this is lead, and lead is a really heavy element, it falls like a lead balloon. So I know lead is heavy, and I think carbon happens early in the periodic table. So I'm going to say that a heavy element would be in the lead experiment and light would be here. So we're looking for 0.1. So at 0.1, we're looking for the interaction most likely. So it'll have the highest probability. So at 0.1, the most likely is the Compton effect. It's the dashed line, and that's the Compton effect. So G and J are out. For the heavy one at 0.1, what's the most likely event? What's the highest P? Is this solid line, that's photoelectric effect. So we have those two here, and the answer is F. So that's a little bit outside knowledge. You would have to know that lead is a heavy element. You don't necessarily have to know that carbon is light. You kind of be able to guess that one of them's light, one of them's heavy. But yeah, that's just outside knowledge, and if you didn't know that, then you'd maybe just have to guess on that one. But anyway, that's that passage done.